welcome to another deep dive. Today we're tackling a question that might keep you up at night. What if our universe is actually inside a black hole?
Yeah, it's one of those ideas that sounds like pure science fiction,
Right.
but the more you dig into the actual science, the more intriguing it gets.
Totally. And that's what we're all about here, taking these mind-bending concepts and grounding them in real physics and cosmology.
Exactly. We'll be drawing from general relativity
All the good
to
stuff.
see if this idea holds any water. So whether you're prepping for a debate or just insanely curious about the universe,
Or just love a good head-scratcher.
get ready for a wild ride.
All right, so before we jump into this whole universe and black hole thing, we got to make sure we're all on the same page.
Right back to basics.
What exactly is a black hole anyway?
A black hole is a region of space-time where gravity is so intense
Intense
that nothing, not even light, can escape.
Whoa.
They often form when massive stars collapse at the end of their lives.
So all that star stuff gets squeezed into...
Squeezed into an incredibly dense point.
Like, how dense are we talking?
We're talking infinitely dense.
Infinitely.
That's right.
Yeah.
It's called a singularity.
A singularity. Okay, so is that where physics kind of goes out the window?
Pretty much our current understanding of physics breaks down at the singularity.
Right.
And surrounding that singularity
Okay.
is the event horizon. It's like a boundary.
A cosmic fence.
Yeah, you could say that. It's a point of no return. Once you cross the event horizon, there's no coming back.
Yikes. All right. So we've got these super dense, light-eating monsters out there in space.
Right.
But how do we go from that to our entire universe being inside one of these things?
That's where things get really interesting.
Okay, lay it on me.
Well, for starters, our universe is expanding.
Right. We know that.
And guess what else is expanding?
Don't tell me.
The space-time inside a black hole.
No way. So
Okay.
the way our universe is expanding is similar to what's happening inside a black hole.
It's a parallel that's hard to ignore.
Yeah.
And there's more.
Mm-hmm.
Certain types of black holes called Schwarzschild black holes.
The math behind them suggests they could actually contain a structure that resembles a universe.
Wait a minute. If the math works out, does that mean it has to be true?
Not necessarily. The math might suggest it's possible,
Right.
but it doesn't provide concrete proof. Think of it like having a blueprint.
Yeah.
Without the building material.
I see. So the math is a clue, not a confirmation.
Exactly.
So what other clues point to this crazy idea? What other theoretical frameworks support this?
Oh, we can't talk about black holes or the universe without bringing up Einstein's theory of general relativity.
Of course. Good old Einstein.
It's the foundation for understanding both.
Right.
And what's really fascinating is that his equations hint at these potential overlaps between black holes and the universe's behavior.
So Einstein's work is kind of giving us a nudge saying, hey, there might be a connection here.
Exactly. And then there's the concept of white holes.
White holes.
They're like the theoretical opposites of black holes.
Okay. So instead of sucking everything in.
Everything explodes outward,
Yeah.
matter and energy just erupting.
So you're suggesting that the Big Bang,
Yes.
the event that kicked off our universe,
Could have been a white hole erupting from another universe's black hole.
that's insane.
It is a mind-blowing concept.
It really is.
Yeah.
Okay, my head is already spinning. But is there anything else that backs up this wild theory? Anything else?
One more for you.
Hit me.
The holographic principle.
The what now?
It suggests that our 3D universe might actually be a projection from the 2D surface of a black hole.
Wait, so like a movie projected onto a screen.
Kind of like that. Think of it like a hologram, but on a cosmic scale.
Okay, that is trippy. So our whole universe is just a giant cosmic film.
It's one of the most mind-bending ideas in physics.
I can see why this is such a captivating topic. It's like peering into the deepest mysteries of the universe. Hold on. If we're really in a black hole, wouldn't we experience some crazy gravitational effects?
That is one of the main challenges to this hypothesis.
Okay.
We don't observe the extreme gravitational forces you'd expect. If we were truly inside a black hole,
Okay. So on one hand, we've got these fascinating parallels and mind-bending theories. But on the other hand, we have a lack of hard evidence and some serious conflicts with our understanding of physics.
right, it's like we're piecing together a puzzle, but some of the pieces seem to be missing.
A cosmic puzzle.
Exactly. A puzzle that might take decades, even centuries to solve.
Well, I don't know about you, but I'm ready to dive into this puzzle.
Let's do it. And it's a puzzle that forces us to confront the limits of our knowledge. But you know what? Even grappling with these questions, it expands our understanding of the universe.
Yeah, it's like exploring a vast, uncharted territory.
Right.
You never know what you're going to find around the next corner. Speaking of uncharted territory, this whole idea raises some big questions about the multiverse.
Absolutely. If our universe exists inside a black hole, it opens up the possibility that there could be countless other universes out there.
Whoa.
Perhaps each originating from a black hole in another universe.
Okay, so we're talking about like a chain of universes, each nested within a black hole. But how could these universes even be connected? And how would they even form in the first place?
Well, remember that troublesome singularity at the heart of a black hole.
Yeah, the point of infinite density.
Right. Some theories suggest that the extreme pressure and energy there could trigger a sort of bounce.
A bounce.
A rebounding effect that births a new expanding region of space-time.
Actually, a big bang happening inside a black hole. A nested big bang.
That's the idea. Imagine a cosmic cycle of death and rebirth.
Whoa.
But on a universal scale, one universe collapses into a black hole, and from that collapse, a new universe springs forth.
That's incredible. So no ultimate beginning, no ultimate end, just this eternal cycle of universes collapsing and giving birth to new ones. It's enough to make you question the very nature of time. Is it linear or is it cyclical? And what happens to information when a universe collapses?
Those are questions that continue to baffle physicists and philosophers alike. Does information get destroyed? Or is it somehow transferred to the new universe?
Are there like echoes of past universes embedded in our own?
It's a fascinating possibility.
It really is.
Yeah.
But let's shift gears for a moment. Let's say, just for argument's sake, that this wild idea is true. Would it change anything for us here on Earth?
Practically speaking, our daily lives wouldn't change. The laws of physics that govern our world wouldn't suddenly shift. But philosophically, the implications are profound.
It changes our entire perspective on our place in the cosmos.
Right.
Suddenly, we're not just inhabitants of a single universe, but potentially a small part of this unfathomably vast structure.
It forces us to reconsider what it means to be part of this interconnected web of existence. It raises questions about our significance in the grand scheme of things. If our universe isn't unique, if there are countless others, does that diminish our importance?
Or does it make our existence even more remarkable? It's like realizing your family tree is much larger and more complex than you ever imagined.
Exactly. It's both humbling and exhilarating. You know, this whole exploration highlights the deep connection between science and philosophy.
Oh, absolutely.
Science unravels the mechanics of the universe,
Right.
while philosophy grapples with the meaning of it all.
And sometimes, as in this case, those two pursuits collide,
They do.
leading to some truly mind-bending questions. Questions that may not have definitive answers, but they challenge us to expand our thinking.
Precisely. It's a journey of discovery that pushes us to confront the limits of our knowledge and imagine possibilities that lie beyond our current understanding.
I'm ready to journey further.
Yeah.
What other clues suggest that we might be living inside a black hole? Okay, let's get to those clues. What evidence suggests our universe might actually be tucked inside a black hole?
Let's go back to Einstein's theory of general relativity.
Okay.
It's not just about black holes and the universe's expansion. It also hints at a deeper connection between them.
Okay, remind me, what kind of connection are we talking about?
General relativity predicts that massive objects warp spacetime. And this warping has actually been observed.
Right, like how light bends around massive galaxies.
Exactly. It acts like a cosmic magnifying glass. But here's the thing. The math suggests that this warping inside a black hole could create conditions that mirror the expansion of our universe.
So the stretching of space-time within a black hole is similar to how our universe is expanding.
It is. It's as if the expansion we observe
Okay,
is a reflection of the warped space-time inside a black hole.
I see.
But let's add another piece to the puzzle.
Okay.
The cosmic microwave background radiation.
Ah, yes. The CMB. That faint afterglow of the Big Bang.
Yeah.
It's like one of the strongest pieces of evidence we have for the Big Bang, right?
Exactly. It tells us the early universe was incredibly hot and dense. But here's where things get really interesting. Some researchers think the patterns we see in the CMB might actually be remnants of information that fell into a black hole in a previous universe.
Are you saying the CMB could be like a message from a past universe, like a cosmic postcard?
It's a speculative idea, but the theory suggests that information isn't necessarily destroyed when it enters a black hole. Instead, it might get encoded onto the event horizon, that boundary of no return.
So the black hole saves a copy of the information.
You could say that.
And when a new universe is born from that black hole, that information is imprinted on the new universe's CMB.
It's a mind-blowing possibility and one that researchers are actively exploring. It suggests a connection, a continuity between universes that we're only just beginning to understand.
Okay, I'm starting to see how these pieces fit together. It's like a cosmic detective story uncovering clues to this mind-boggling mystery. But there's still the problem of the singularity.
Right.
How can we even wrap our heads around a point of infinite density?
That's the challenge, and it's where our current understanding of physics breaks down. We need a more complete theory of quantum gravity
Right.
to truly grasp what's happening at the singularity. But in the meantime, we can still look for more observational evidence
Right.
to support the black hole universe hypothesis.
What kind of evidence could point us in the right direction?
Imagine finding specific patterns in the CMB that could only be explained by information leaking from a previous universe.
Okay.
Or perhaps we could detect gravitational waves from colliding black holes that have unique properties aligning with this model.
So the hunt for evidence continues. It's like searching for a cosmic needle in a haystack.
It is. But even if we don't find definitive proof, the journey itself is fascinating. It pushes us to the limits of our understanding and forces us to ask some truly profound questions.
Absolutely. The black hole universe hypothesis is a powerful reminder that the universe is far stranger and more complex than we can possibly imagine.
It is. It's a reminder that there's still so much we don't know, and that's incredibly exciting.
This deep dive has been a wild ride, exploring these mind-bending concepts and pushing the boundaries of what we thought was possible.
I agree. It's a journey that I encourage all of us to continue. Keep those minds open, keep asking those challenging questions, and never lose your sense of wonder.
That's a wrap for this deep dive into the question, what if our universe is inside a black hole? Thanks for joining us. Until next time, keep exploring the mysteries of the universe.